Alright, let us look at another question where we are asked to evaluate the limit of x by x minus 2 minus 4 by x square minus 2x as x approaches 2. Limit as x approaches 2 of x by x minus 2. I'm going to rewrite this as x into x minus 2. Now the first step always is to try to substitute this directly into the function and see what we get. So we'll say try x is equal to 2, which gives us 2 by 2 minus 2 is 0, minus 4 by 2 minus 2 again becomes 0. So 2 by 0 is infinity, so is 4 by 0. So therefore we end up with infinity minus infinity, which is indeterminate. And the second thing we note is x minus 2 must be a common factor. So let's rewrite this expression by taking LCM and converting it into a single rational function. So the LCM would be x into x minus 2. Since x minus 2 is already present here, so we just need to multiply with x. So the first term becomes x square and the entire LCM is present here. So this term remains as minus 4. Now you can already notice that there is x minus 2 as a factor in the denominator. All we need to do is to factor this x square minus 4 as x minus 2 into x plus 2. So this becomes limit as x approaches 2, x minus 2 into x plus 2 divided by x into x minus 2. Now we realize that this x minus 2 term is what is dragging this entire function to the indeterminate form. So therefore we chop it off and then we declare as x can never be equal to 2. So we are left with the limit as x approaches 2, x plus 2 divided by x. Now we can safely substitute x is equal to 2. So we say put x is equal to 2, which implies 2 plus 2 divided by 2. That's 4 by 2, which gives us 2. Therefore, limit as x approaches 2 of x by x minus 2 minus 4 by x square minus 2x is equal to 2. And that is the final answer. Alright, let us look at another question where we have been asked to evaluate the limit of 1 upon x square plus x minus 2 minus x by x cube minus 1 as x approaches 1. So let us note down the question. Limit as x approaches 1, 1 by x square plus x minus 2 minus x divided by x cube minus 1. So if we try to put 1 into the function, let us see what happens. Put x is equal to 1 implies 1 divided by 1 square plus 1 minus 2 minus 1 by 1 cube minus 1. So clearly this denominator becomes 1 plus 1 is 2 minus 2 0, and this clearly becomes 0 as well. So we are left with an infinity minus infinity form, which is indeterminate. Since we ended up with an indeterminate form, we can try to pull out the common factor, which in this case would be x minus 1. So before we pull out x minus 1, let us try to convert this whole thing into a single rational function by taking an LCM. Even before that, we need to split this into its factors, which we can do by splitting the middle term. As x approaches 1, this becomes x minus 1 into x plus 2. And then we write this denominator as x minus 1 into x square plus x plus 1. Now, if you remember, a cube minus b cube can be written as a minus b times a square plus ab plus b square. And I have used this identity in order to express x cube minus 1 as x minus 1 into x square plus x plus 1. Now, I can clearly see x minus 1 is common. So that comes in the LCM, x plus 2 and x square plus x plus 1. So the first term becomes, since I have x minus 1 and x minus 2 here, this term will feature here. So I'll write x square plus x plus 1 minus x into, if you notice I have x minus 1 and x square plus x plus 1. So all I need to write here is x plus 2. And of course the limit as x approaches 1. So this thing becomes limit as x approaches 1 of x square plus x plus 1 minus x square minus 2x whole divided by x minus 1 into x plus 2 into x square plus x plus 1. So the x squares get cancelled and then I get x minus 2x is minus x and there's plus 1. So this whole thing reduces to x approaching 1 1 minus x whole divided by x minus 1, x plus 2, x square plus x plus 1. Now I can almost cancel these two terms. The only thing is I need to take minus common in the numerator, so that will make it x minus 1. So this becomes the limit as x approaches 1. I'm taking minus common, so I can write x minus 1 here, and then I have x minus 1, x plus 2, x square plus x plus 1 in the denominator. Now I can safely cancel these two, as I declare x can never be equal to 1. So what I'm left with is, as limit of x approaches 1 minus 1 divided by x plus 2 multiplied by x square plus x plus 1. Now I can safely substitute 1 into this entire function. Let's see what happens. So put x is equal to 1, which implies negative 1 whole divided by 1 plus 2 into 1 square plus 1 plus 1. So this becomes minus 1 by 1 plus 2 is 3, and this is 3, so that is 9. So the final answer is the limit as x approaches 1 of 1 upon x square plus x minus 2 minus x upon x cube minus 1 is equal to negative 1 upon 9, and that is the final answer.